So like I said, we're going to look at systems with alternative kinds of functions, lines, parabolas, and exponential functions. So the first one, we've got two inequalities to be concerned about. So what kind of inequality is the top? Is that a line, a parabola, or an exponential, guys? It's a line. I see mx and b. It's just they're not quite ready yet, right? So we need to manipulate it so it's ready to go. The parabola is already in transformation form, so it should be ready to graph right away. I'm really going to go over transformation form so people like Cody, who's going to need to pay close attention, are aware of what's happening there, and so you guys get a real refresher because some of us are not clear about it yet either. That's heavy, big stuff in Algebra 2. So let's see. We need to solve for y here first. So what should I do first, guys? Move the x. Right? So I'm going to rewrite the system. This is definitely the best way to go. It's a little bit long, but it'll pay off. I don't need to touch the second one at all. I'm going to do one more thing. What else do I need to do to get y by itself there, guys? Divide by -5. Do I flip or not on this time?
No.
Was negative, so I switch directions. So yes. So this sign needs to flip this way. 20 divided by -5, comes out. -4. Negative over negative is positive 4/5. We'll just leave that. And the parabola is done, as I said. All right, I think we're ready to graph this one. Okay, so my line, where should I start graphing my line? -4 where? Down, left? It's the y-intercept. 1, 2, 3, 4. I'm going to try to draw this one fairly nice. So -4 right there. Slope says go up 4. Oh, nice. 1, 2, 3, 4, 5. I think that my tick marks are not the same size. Oh well. Dashed or solid line? That says dashed. Okay, now that you guys are getting some more complex inequalities, it's pretty essential, you'll find later, to label the edges. So what is this equation? I'm going to say this is y equals -4 plus 4/5 x. And it's equals because that's the actual edge. Does that make sense? Label your edges. It's a good habit. So, now we need to do the parabola. So what does this +6 do to x squared? Does it move it up? Does it move it left, right, down? If you take all the points on the curve and you add 6 to every one of those points, it goes up and down. Remember, if you have stuff outside of the squared, that's a vertical movement. And up is up, down is down. So we should go up 6 for our parabola that started right here, right? That's just x squared. So I'm going to move the vertex up 1, 2, 3, 4, 5, 6. And then I also need to move it where? That -3 inside. Inside is going to move the parabola left or right, and it's opposite. Inside transformations are always opposite no matter what kind they are. So -3, even though you think -3 lives over there, which is good, -3 means move to the right. So let's write that down on our parabola. Inside is opposite, so that's going to be right by 3. Outside is vertical and what you expect, so it's going to be up by 6. So up by 6, right by 3, and this parabola, guys, up or down is it going to open? I don't see any negatives or anything, so it's going to open up from there. Solid or dashed?
Solid.
That says solid. So I'm going to open up like this. Okay, so we're supposed to be, let's refresh, the blue line. I'm supposed to be below or above? Below. The parabola. I'm supposed to be below or above? Above. I wasn't thinking ahead on this problem. How many solutions will work for both? None. This is a no solution problem. How could I make it a solution problem real easily? I could do all kinds of things. I'm just going to flip one of those inequalities, okay? So let's just flip this one. Let's say I originally had meant to go underneath. So if I'm underneath the parabola and underneath the line, would this point count? It's under the parabola, but it's not under the line. Would this point count? Under the parabola, but not under the line. What are the only points that are going to count? This one? It's under both. This one? It's under both. Really, this answer set is just the answers that are under the line, because all of those are also under the parabola. So that one we had to use a little bit of logic. Let's look at another problem. So I'm going to erase so we have some space. All right, so this one has 3. So x equals, or less than, or whatever, x equals, is that vertical, horizontal, or diagonal? It's vertical because it's x equals. So at 4?
Yes.
Solid or dashed?
Solid.
Labeling my edge. We'll shade it in a second. Here we've got another parabola. You guys help me out. What does this 1 minus 1 outside do? Yeah, you're right. I'm going to say that moves it down 1, but that's what you're saying, Colton. I like it. Okay. What's this plus 2 inside do?
It goes left 2.
Inside is left to right and opposite. So Richard is correct. That's left 2. Now what's this minus do?
Make it open down.
Yep. That's going to flip it over or make it open down, however you want to say that. So we're going to go and draw that guy. I had red, so let's use red. So let's see. Left by 2, down by 1. Here's the vertex. Opening down and solid or dashed? Dashed. Just going to kind of sketch it. There we go. All right, exponentials. That's what Mr. Fisher did with you guys, but I think it was not enough. So we'll definitely do a lot more with exponentials next year. Yeah, I'll go from the beginning. But transformation-wise, the same thing we did with parabolas works for all other functions. The thing I'm guessing you guys do not remember is what the function 2 to the x looks like. 2 to the x is exponential growth. It grows from the beginning for all time and looks like that. And if you put 0 in, what do you get at 2 to the 0 power? You guys should know that. 2 to the 0 power, anything to 0 power is always 1. So this is 1 right there. If you put like 1 in, 2 to the 1 power is 2. If you put 2 in, 2 squared is 4. If you put 3 in, my graph's not to scale, but 2 to the 3rd power, 2 times 2 is 4 times 2.
I mean, it's
2 times 2 is 4, times 2 is 8. This is going to be essential in Algebra 2, this kind of counting, which I'll start class with. That's one of the first things we'll do. Is learn to count like that really good, really well. So that's what an exponential function looks like. This one has a transformation applied. You guys tell me, you've never probably seen this before. Is that transformation happening inside the function or outside the function, that plus 2 thing? Is it inside or outside? The inside of this function isn't inside the squared. It's the top. So it's inside. And plus 2 inside meant which way? Left, right, up, or down? It was left. Just like that problem here. It's the same thing as this, except we're taking this shape and moving it left by 2. So let's write that down. This is also inside. It's left by 2. So I'll do this one in green. That shape I'm going to scoot over left by 2. So this point that was at 1 is going to be left by 2 right here. And then I'm just going to kind of sketch it. And should my green exponential function be green, be solid or not? Solid or dashed?
solid. Solid.
This should be solid. Okay, now let's see if we can figure out where to shade this. And I should label my edges, right? Let's label our edges. So to shade the overlap in blue. So one at a time. Should I shade left or right from the 4? Do I want things bigger than 4, x-wise, or smaller than 4? Smaller than 4 things are over here. For the parabola, should I shade above or below it? Below it, right? So I'm thinking in here, to the left over there. Eventually this parabola is actually going to come over and cross this, even though it doesn't look like it. So I'm going to be inside the parabola over there. And then for the green guy, should I be shading above or below it? Above it. Crud. So we'd have no solution again. There's no point that's above the green, to the left of the blue, and below the red, I don't think. So let's fix this guy. Your worksheet won't have those issues because I was more careful. So, it could, though. I mean, these are totally legit questions, right? This just has no solution. So you wanted to make the parabola be above? That'll be an interesting answer. I like that one. Very nice. So we're going to try to make this a little bit artistic, our answer region. I think this one will be a little more interesting. So let's go above the parabola. So we're up here, right? Let's make it be below the green line. Green exponential, I should say. And then we'll leave the other one alone. So now this says be below green. And you can make little notes to yourself. That'd be a really good suggestion. So as soon as you realize that, just put, I'm below this one. I'm above this one. I'm to the left of this one. Those are really good notes to make to yourself if you're getting confused. So left, below, above. Here's an interesting answer solution. So we've got all the points in here that work up to this edge, then in here, up to right there. So it's like a little triangle kind of thing. And then it's going to end wherever this edge is there, like another little triangle kind of thing. So those are our solutions for this problem. Okay, so a little more interesting, yes? Let's look at another kind. All right, so this one says do the reverse. You're given the picture, write down the system representing that picture. So how many pieces, how many inequalities should be in our system for the first one, guys? 2, right? There is one of the pieces will be a line, the dashed one, right? And the other piece will be parabola or exponential? Exponential, it doesn't look like a parabola. This exponential looks a little different though, right? It's been what? It's been flipped over, just like when we flipped parabolas over. That's no different. Okay, so 2 pieces. Let's try to get them. The lines should be pretty simple, I think. So we'll get a nice system bracket that says you have to solve them simultaneously, right? So mx plus b, how's that going to go? More than or less than from the line? Above or below is the green spot? If you're less than, I'm looking at the line. I'm thinking above the line or below the line. So it should be greater than. No equals to, right? It's dashed. And where's the y-intercept on that line? -3. Doesn't matter if you put the y-intercept first or second.
-2x.
And the slope is -2. Let's look at that. I think that Sheridan's probably looking right here to there and going, that's down 2 over 1. So that's going to be -2. Slope gets the x. Done for that guy. Now the exponential function might be a little bit tricky. So the first thing that's a little bit tricky, which I won't give you anything hard on your problems, it's basic. What power? Because you could be 2 to the x, 3 to the x, 4 to the x, 1/2 to the x. There are all those options. I'm not going to ask you anything tricky. Like I said, there's some points on there on the exponential which should tell you which one it is. Do these y-coordinates look like powers of 2, powers of 3, powers of 4, powers of 5? They look like powers of 2, just like the other problem. So I think we're going to have something with 2 to the x. All right? Now I don't think it's been shifted because it goes right through 1, like the basic one I drew a second ago did. But you guys told me it was flipped at the very beginning, right? So where should I put a negative? Don't you usually just put it in front when we did parabolas? There's more to it than that, but for this year we just know that to flip it over this way, you put the negative in front. I'll tell you, to flip it over that way, which is totally possible, you don't put the negative outside. Horizontal stuff goes inside, so we put the negative on the x inside if we wanted to do that. Okay, and what do you guys think? Less than or more than for the exponential? We're below it. Less than or equal to, great. So we're going to be y is less than or equal to, and I think that's it. Oh, and by the way, you can put these in your calculator to check your answer. I'm not going to show you how to do that if you'd like to figure it out yourself. Nice, it'll shade these for you and everything. It's a pretty good way to check. All right, this one, how many pieces? 3. So I tried to make the bracket big. It didn't want to make it real big when I did your little paper, so beware, there might be 3 on some. So let's do the easiest one first. I think this one's the easiest one. It's a flat line that's y equals, and not equals, right? But y and 6, and what goes in between? Less than, because we're below. Done. Let's go for the other line, because lines are pretty easy. Let's see what we got. Mx plus b, I think we'll have an equals to above this line or below. Above. Intercept is 1. Yes, what's up?
How would it be below?
On which one? This one?
Yes.
Yeah, because like the red area is clearly up below it, isn't it? It's like this point's below, this point's below. All that red part is below. That's why we put less than. Does that make sense?
Yeah.
Okay, good question. Got another one? Ask it. So 1x or not?
No. Yeah.
It's the y-intercept, so no. And then coincidentally, there's also 1x. Oh, that was a terrible question because this one also has a slope of up 1 over 1. 1 over 1x. That's really just 1x or x. The y-intercept's also 1. Crazy. Boring line. Anyway, the parabola. Can you guys help me with the parabola? We know we're going to get a squared, right? So let's get our squared on there. Below or above it? These are all below the parabola, right? So less than, and it's dashed. And let's see, our parabola, where was it moved from here?
Plus 6.
It was moved 1, 2, 3, 4, 5, 6 that way, so I should put plus 6. I agree, you guys are right. Inside or outside? Inside with the x. And then parabola was also moved which other way? It's moved up. I tried to make that look like up 2. So plus 2 or minus 2? Plus 2, and outside's all the space I left, so yeah. Up stuff or down stuff happens outside. I think that's it. That's the solution region for that one. What's up?
Would you be able to distribute the square to the x and the 6?
Okay, so remember, we viewed parabolas most of the time this year. We didn't look at parabolas in transformation form, right? We looked at parabolas. It's a great question. Can't just distribute, you've got to expand, right? The other form of this parabola, which you'd see, is x plus 6, x plus 6. So most of the time this year when we worked with parabolas, they looked something like this, right? They went x squared, 6x and 6x for both of those, and then what's this? 36. So I could totally have written this parabola down too. This parabola and that parabola are the exact same parabola. This one is much easier to graph quickly than this one, because for this one, we went through the process. You guys should be able to do it. You'll need to for next year. You'd do negative b over 2a to find the vertex, and it would come out to be right there. And then you'd need to think up or down, and it would be going up. But to figure out the vertex was right there, negative b over 2a would give you negative 6. And then you'd have to plug that into the parabola to get 2, and you'd get the same information. You can see that this is a much quicker way to graph them. And going between this and this is something we'll really focus on in Algebra 2, because sometimes it involves some trickier math. So, great question, Lindsay. All right, so last problem for today, going back to our graphing calculator. So these ones say, use your graphing calculator to solve the system. Otherwise, you'd need the quadratic formula for this one. It says one of them is a line, and the second one is it's a parabola, right? Second one there. So we're going to do this graphically. So we're going to solve the system graphically. So where do we go if we want to graph things in our calculator? Remind me. Y equals. All right, I've got a plot on. If you do, you probably don't, but if you do, turn it off quickly like that. You definitely want to follow along with me if you aren't. So I've got 2/3 x minus 1. So I'm going to go 2/3 like this. If you want to use alpha y equals, by all means. So 2/3 x minus 1. There we go. There's my line. Now I'm going to do my parabola. X squared minus 6x plus 7. And we could, of course, graph what this looks like. We did that bunch just a second ago, but I'm just going to get my calculator's graph. Oh, I didn't follow my own advice. What should I have done? What should I always do first? I should have pressed zoom 6, right? There's the line. I think it should look like you expect. We'd have to fool around with that parabola, but there you go. This time I don't care about the picture because these are not inequalities. They're equals. This wants the points that work for both. How many points work for both? That's where they cross. That's one answer. And that's where they cross. Doing this by hand graphically would be completely impractical, impossible pretty much. But your calculator can do it. So we're going to find where they intersect by going second, calculate or trace. And using which thing? Intersect. We've done this before. And I'm going to first try to get this answer right here. So it says first curve. Remember, you go on the left. Then you scroll on the other curve to the right-hand side of it. And then you guess at it as close as you can be. And it will compute the answer. Look how complex that answer is there, guys. You see it? I'm going to make it focused a little better. There's no way you'd ever guess that. It comes from the quadratic formula. I could show you how to solve this by hand, but I think it's a little much for today. So one of our answers, x, y, is about. Use my about sign and go 1.569, bless you, and 0.046. I'd like you to, if you're watching the video for the worksheet, I'd like you to go 1,000 place rounding, through 3 decimal points afterwards. That's one answer. Other one you can also get. So second, calculate intersection. And I will bet money that on Park they will definitely probably have you do this in a couple problems, whether for their systems or something else. They're definitely going to have you do something like this. We did last year at least, so knowing how to do this is essential. And I agree with them. They're totally right to ask you guys how to do these problems. Very important. So there you go. There's 2 answers to that system graphically. Those are the only 2. I don't think that the line's going to cross again because it can't bend. All right.